Alright, hello everybody. We're in section 3.4 and we're going to look at the dreaded piecewise functions. So, it's a good name. It's called a piecewise function because it's comprised of different pieces of different functions. So here I have f of x equals, and this is my piecewise function. First of all, there are three pieces to this. This is the first piece, this is the second piece, and this is the third piece. Only use one piece at a time. So some basic questions. Question number one. What is f of minus 2? Okay, so here I'm telling you the input and asking for the output. So f of minus 2. Over here, this tells you where to look. This is like the domain. This is for the inputs. So minus 2, where does minus 2 live? Is it less than 0? Is it equal to 0? Is it greater than 0? So here, f of minus 2 is definitely less than 0, so I'm going to use this top layer. And this is the piece of the function I'm going to use because this x value lives here. This x value is less than 0, so I'm going to plug it into the top equation. Let's see, minus 2 plus 1, and then I'm going to do the algebra. It's minus 4 plus 1, which is minus 3. And that is my answer. Remember, it's a function, so you have to give, for every input, you only get one output. You can't plug minus 2 into everything you see, because you only use this function when you've got a negative x value, which is exactly what this is. Alright, so let's say, well now, what is, so find f of 3. So here, where does 3 live? Is it less than 0? No. Is it equal to 0? No. Is it greater than 0? Yes. So this is the function I'm going to use. I'm going to plug 3 into there. When I plug in a 3, I get 9. Let's see, what is f of 0? Well, that's exactly what this middle line tells you. The function equals 5 if x equals 0. That's what I want to know. If I put in a 0, what does the function spit out? And the answer is 5. Okay, let me give myself some more space and let's see if we can get a graph of this. Okay, it's graph. Let's see, I've got three pieces. So I'm going to start with this bottom one. So the function looks like x squared if x is greater than 0. So here, this function takes over for all the positive numbers. I'm still going to kind of put 0 into this function. If I plug in a 0, I get 0 squared, which is 0. What I'm going to do is I'm going to do an open circle here. And then this from the library functions, we know looks like quadratic. If I plug in a 0, I get the number of 5s. 1, 2, 3, 4, 5. And that would be a closed-in circle. That's what closed-in circle means, equal. And now I have to graph this last part. So I'm still going to throw a 0 into here. 2 times 0 is 0, plus 1 is 1. It's an open circle. And here I have a linear function, so I need one more point to graph it. I'm going to plug in a minus 1. If I plug a minus 1 into this guy, I end up with minus 2 plus 1, which is minus 1, which is down here. And boom, that guy looks linear. And those are my three pieces. It's a line when x is less than 0. It's the number 5 when x equals 0. And it's x squared from then on out. That's the graph of this piecewise function. So let's try it the opposite way. Let's see if we, given the picture, if we can get the equation out of it. So let me get some more space. Okay, we're going to try to find the equation of this piecewise function. So first of all, is this the graph of a function? The answer is yes. Every vertical line would intersect this graph in at most one place, even right here on the y-axis. This is an open circle, so it only exists right here. This function looks to me like I've got two pieces. This is the first piece, so this is piece 1, which is a line, and this is the second piece, piece 2, and it's also a line. So let's look at the first line. So line number 1. Remember, we only need 2 points to get a line, and we have that. So line number 1, we have the points. Let's see, this point is minus 2, minus 2. And I have the point 0, 0. Okay, so I'm going to let this be x1 and y1, and I'm going to let this be x2 and y2. So first off, we find the slope. So y2 minus y1 over x2 minus x1. Double negative, this is 2 over 2, which is 1. And then we're set, because remember, I have the y-intercept right here. So this is my b value. So y equals 1x plus 0, which I'm going to clean up to y equals x. So that is this part of this line right here. Let's find the equation of this second piece, this piece over here, so line number 2. For the second line, I have the point 0, 3, and we have the point 3, 0. So again, I'm going to let this be x1, y1, and this be x2, y2. And it's okay that this is open. I can still use it. I still want to find the equation of the line passing through these 2 points. I'll just make an adjustment when I write the equation of the function, because this is an open circle. So let's find our slope. y2 minus y1 over x2 minus x1. Watch those signs. This looks like minus 3 over 3, which is minus 1. Whoops. Back. Sorry about that. And here we go. Let's see. Do I have the y-intercept? Yes, I do. Here's your y-intercept right here. Otherwise, do point slope and then put it in y equals mx plus b. The equation of this line is y equals minus 1x plus 3, because there's your y-intercept right there. So again, clean this up. Y equals minus x plus 3. Alright, here we go. I'm going to try to put this all together. Okay, now I'm writing the equation of my piecewise function. So I've got an f of x equals, I've got a curly bracket, and I've got my 2 pieces set up. So here's x, that's for line number 1, and here's minus x plus 3, which is line number 2. Now, all I have to do is put the restrictions in here. So for this first line, I'm looking at x values here. Equals x if, well, let's see, when do I start using this line? Right over here, this is the point minus 2, and this is the point 0, 0. So my x values here are minus 2, less than or equal to x, are less than or equal to 0. Underline on both of them because these are 2 closed-in circles. Now this line, I have the point 0, 3 and the point 3, 0. So I'm going to use this if now this guy takes over, but it's an open circle here. So I'm going to go 0 is less than x, is less than or equal to 3. And this is my equation of this piecewise function. I know piecewise functions are hard, so hopefully it's just enough to get you going on it. And that is how to do piecewise functions. It's so awesome we get ourselves in this little smiley.